Welcome to this second video on how we make SendaBeam.com GIFs. This one looks into the practical aspects of how we make them, and there's quite a lot of ground to cover, so we'll get started straight away. Here we are down in the workshop, and I shall show you the components of the machine. This is the mirror that we use for each individual sender. You'll hear a lot of fuss on when they build a big telescope about the mirror. They go on and about the mirror. Well, the mirror is extremely important, and it's quite difficult to get a really good shape, and I've actually had to have these made. You just can't get a mirror that will fulfill the specifications that we need. Moving on to the LED itself, here you can just see the LED. It's not focusing very well, but it's that tiny little speck just there, and it's mounted on a copper bar that then fits inside a bit of drain pipe. I'm afraid it's all very utilitarian, and there's a slot so that you can lift it up and down, focus it. It can be moved from side to focus as well. And this is the main sender that we've seen so many times before. The information comes down this cable to an Arduino, a little microcontroller that converts the information from the laptop into the pulses, the on-offs. These 7 things on this breadboard are relays, and they take the small output of the Arduino and take the large input from the battery so that we can switch the lights on and off without blowing up the Arduino. These are 7 little converters that convert the 12 volts from the battery down to any voltage we want. It's about 3 volts on-off switch. And then the massive wires. I've made 7 individual channels completely individual so that I don't have any strange happenings with the circuitry. And then there you are, the 7 sender units fixed together. We're outside now, and we'll have a look at the setup in the daylight for getting the star shots. There's 3 parts: the laptop, the sender unit, and this video camera for recording the video from which we get the GIF. The sender unit is lined up with a star simply by moving the base or the lights on the frame. There is this little scope which we can get an accurate sighting with, but generally I find these beams are wide enough to do it manually just by sight. If we used lasers, it would be much more difficult, and there'd be a good chance of missing the target altogether. On top of that, there's aircraft. I think it's plain illegal just to shine lasers into the sky. I still turn it off when an aircraft goes by. I don't want to distract the pilots. The camera I adjust manually for each GIF. I did think about mounting it on the sender unit so that it would be in the same position, but that means that all the GIFs would be from the same angle, and if I set it up each time, then every GIF is an individual angle, and that's why some of the GIFs look different, because I might have the camera around the other side like this to take another shot, or obviously if we're going nearly vertical, then I've got to adjust the position of the camera. I'm usually fumbling around in the dark. This veranda faces west. We've got quite a nice sunset today, and that's south over there. It will take time to get all the GIFs because not all the stars are visible during any one day. It's going to take several months, and also because the viewing conditions aren't always perfect. I mean, sunny Cyprus has 3,400 hours of sunshine, but look, we're not going to get anything today with these clouds tonight. So it all takes time, and that means that the GIFs and the NFTs can only be released at a certain pace. Let's have a look at how the data side of the star catalogue is created. We start here with Wikipedia, this list of stars by constellation, which you can of course visit. Then when a constellation comes into view that we can take the star shots of, I go to that list of stars in the relevant constellation, and I think we'll stick with our example of Canis Minor and Procyon. It's a nice little constellation and we'll use this as our example. I extract the data from this table and I only go down to 4.4 magnitude. So on the visible magnitude column, I would select the top 4 entries here, and then I would take them and put them into my spreadsheet on Excel. But before we do that, I want you to have a look at the 4th star on this list. And if you look under name, it's got the HD, the Henry Draper designation instead of a name. And I just want you to remember this number HD 66141. While that number's still in your head, I want you to see that on my list here, the HD number 66141 is there, but I've called this star 13 pup, and I've actually highlighted this cell to show me that there's an anomaly or something interesting. And this star used to be in the constellation of Puppis, but it has since moved into the constellation of Canis Minor. So what do we do with this star? What do we call it? Well, I've called it this, and Wikipedia avoided it completely by just calling it 66141. So this is an example of an anomaly, and all catalogues have anomalies and even errors. So it's something that's natural. It's not something that anybody will tell you that this particular catalogue is the only catalogue. It's a much more fluid concept. So we take the data here, which has been prepared, put in its columns, and then we hit this button up the top left here, prepare messages. The macro behind this creates the codes as you can see in column B. It also creates a title entry for each constellation. So in row 2 you can see that there's a code, but just the name and the constellation. But it's just like a title GIF for each constellation that groups them together. Then we go to the stars to send screen, and you can see that this is where we actually send the beams. We test the sender, hit send beams, and one at a time they're sent out into space towards their target. You'll notice that the last one is twice, but that's just to do with the way that the programming's set up. I won't bore you with exactly how we create the GIF, that's just standard stuff from the video that we took at the time. But once that's been done, column B gets a green cell style to show that it's been completed. You can also see on the far right, column O, the timestamp which is created when that send beam button is pushed. And there is our constellation Canis Minor with its entries and that interesting out of area 13 Puppis highlighted. I'm going to post this spreadsheet on our website SendaBeam.com, and you can watch it grow. I'm also thinking that it could be a list of all the owners of the NFTs of the stars as well, so keep your eye on that. This section has been a little bit dry and even boring, but if you're going to invest in an NFT, I feel that you need to know as much information as you can so that you know what's behind what you're buying. Thanks for watching this video. If you have any questions, just ask in the comments below or visit us on the various social media and our website. I'll be pleased to help you. This video is number 2 in a series of 2 videos about the SendaBeam GIFs and NFTs. If you want to know about what the GIF pulsing lights actually mean, then go and visit the first one in this series and you'll find all about it there.